Hello, I'm Andy Briggs, and welcome to the amazing Astronomical Alphabet, a weekly programme in which my Astro Radio co-presenter Daz and I will be talking about anything astronomy related which begins with the week's letter of the alphabet. We'll each choose some things to talk about which are in some way related to the universe, but neither of us will know what the other has chosen. We will then reveal facts about them which are weird, strange, bizarre, or simply interesting. Hello listeners, and welcome to another edition of the amazing Astronomical Alphabet with me, Andy Briggs, and him.
Him.
This is Daz. Say hello, Daz.
Hello, Daz. How are you?
Very good. How have you been, Daz? Okay?
Fine, yeah. The weather here is absolutely atrocious at the moment. I'm just looking out the window and it's just starting to rain again. So I've got been looking forward to this. So we got the D's. I've got quite a few, some short, some long, but yeah, it's going to be fun.
Okay, interesting, because we've got quite a few possibilities with the letter D. Just to explain to people who haven't listened before out there in Radio Land, Daz and I have chosen some astronomical terms or things, anything relating to the universe beginning with the week's letter, which, as we said, this week is D. I don't know what Daz has chosen, and he doesn't know what I'm chosen. And we're going to talk about them, chat about them, and reveal some interesting, bizarre, weird, or just plain great facts. So, without more ado, if you're ready, Daz, we'll crack on with the letter D. And I believe it's my turn to go first this week.
It certainly is, yeah.
Okay. Right. So, moving on with D. D is for dark energy. Now, yeah. I was thinking Daz will probably choose that one. But I just wanted to very briefly actually look at a particular aspect of dark energy. And in case any of our listeners don't know, dark energy is what astronomers refer to when they talk about this mysterious something that is forcing the expansion of the universe to accelerate. Now, this is exactly the point I wanted to make, because there's lots of misinformation out there about what exactly dark energy is. And I've read it in loads of places that dark energy is what makes the universe expand. It isn't. It's what is causing the expansion of the universe to accelerate. And the history of it goes something like this. After the Big Bang, the universe was expanding, and that expansion was slowing down, as you would expect. Now, we have to stress again that the Big Bang was not a bang. It wasn't an explosion. You shouldn't think of it like an explosion, because an explosion takes place in an existing space. And at the moment of the Big Bang, there was no existing space, because space itself came into being with the Big Bang. However, the energy that the Big Bang imparted to the universe meant that the expansion was slowing down, as one would naturally expect when energy dissipates. However, about 6 billion years after the Big Bang, something happened. We don't know what that something is. We don't know what caused it, but the effects of it was that the slowing down of the universe's expansion suddenly started speeding up again. So the expansion of the universe started to accelerate. Now, as I said, we don't have any idea what that something was. It was an event. It was something pretty fundamental to the whole structure of the universe. So something really, really basic that affected the whole universe. And it was first detected in the late 1990s by astronomers who were doing a survey of distant supernovae. And to cut a long story short, they found out that the most distant supernovae in the universe were further away than they should have been. And the only explanation for this was that the expansion of the universe is accelerating, and has been since 6 billion years after the Big Bang. Whether it will continue to do so, nobody knows. What's causing it, nobody knows. But obviously there are lots of astronomers and astrophysicists and cosmologists on this particular case who are developing more and more complicated and advanced instruments to find out exactly what dark energy is. It does have the characteristics of something that Einstein called his cosmological constant, which was a mathematical fudge factor that he introduced to stop, theoretically, the universe from expanding, because Einstein did not believe in an expanding universe. It has some of the characteristics of that. Mind you, Einstein later called the cosmological constant the greatest blunder he ever made in his professional career.
Yeah, that's right.
So, so even he wasn't, happy about it, and he realized he'd made a mistake. And we've talked a bit about this on this program before, but I just wanted to just reiterate that dark energy is not the thing that's causing the universe to expand. What causing the universe to expand is still the Big Bang. It's what's causing the expansion of the universe to get faster. And it's still a complete mystery. But apart from the initial supernova survey, it has been confirmed by lots of other surveys using different methods. So dark energy is definitely there, even if we don't know what it is. You got anything to add to that, Daz?
Well, I was just thinking, I mean, the whole concept of dark this, dark that. I mean, basically, when they call something dark, they don't know what they're talking, what it is.
That's fine.
And it's the same with the Big Bang, and it's another misnomer, and singularities in black holes.
Yes.
It's where they've got to the stage where they just haven't really got a clue what is actually happening. Well, they know what's happening, but they don't know what's causing all these effects and things like that.
That's right.
And like you say, talking about dark energy, I did read recently somewhere that they thought that as you said, there wasn't actually a big explosion. You don't see sort of like a blank space, then all of a sudden there's this explosion throwing all this matter and everything around. We had an inflation. We've said this before, and somewhere along the lines, I read somewhere that they think that the dark energy was the cause of the massive, and to use the word sudden doesn't explain it, sudden expansion of the universe, if it coming into existence and all that. But then it switched off.
Yes.
So you had the expansion, then it happily went along doing its thing, forming its stars and things like that. Then, as you said, about 6 billion years in, it suddenly started to expand again. Yeah, so it passed the rate.
And in fact, some cosmologists have said that it may be akin to something called a phase transition. And a good example of a phase transition is when water turns to ice. It turns from one form to another. And they say that that it may have been akin to that, although we shouldn't take that literally as a simile, because it wasn't a type of phase transition that we would recognize, but something along those lines, where the universe went from being in one state virtually overnight to being in another state. But what that phase transition was and what caused it, we don't know. In fact, I was reading rather depressingly the other day one cosmologist saying that he doesn't think that in our lifetime we will understand dark energy because it's too complicated. And what amazes me is that we can understand the universe as well as we can, because we've made tremendous advances just over really the last century, even the last 50 years, in understanding the nature of the universe and how it works. And it was said when I was younger that what we know about the universe is doubling every 10 years. But that rate is definitely accelerating. And we are entering this new golden era of astronomy, astrophysics, and cosmology, where I think over the next decade or two, we're going to make amazing advances in understanding the universe. Would you agree with that, Daz?
Yeah, I would. I mean, as you said, what we've gleaned from the universe and what we know about the universe, we have learned with the improvement of instruments, technologies, and ways of detecting things. I mean, some of these things that we, would never have thought about, radio telescopes, using ultraviolet light to detect things and things like that. In 100 years, we've done really well, because it was only 100 years or so ago that galaxies outside our own galaxy were considered to be nebula.
Exactly.
So, we've come so far and so fast.
And when you think that we now have a sort of a framework for understanding the history of the universe from about 10 to the minus 23 seconds after the Big Bang up to the present day, we have a pretty good idea of what happened, even if we don't have the fine details yet. And for any civilization in the galaxy to achieve that is amazing. Personally, I think it's humans' greatest intellectual achievement ever, understanding the history of the universe back to 10 to the minus 23 seconds after the Big Bang. That's 0.23 zeros and a one seconds after the Big Bang, right up to the present day. We have an idea of how galaxies evolved. We know how stars evolve. We have the whole history of the universe really worked out now. And we've
got a good idea of what's we've got a good idea. We've just got to work out what's going to happen at the end.
Exactly. Well, yeah, that's right. We even have good ideas about the fate of the universe as well.
I mean, there's 4 or 5 different explanations there, but that's for another day.
Yeah, we'll talk about that.
That was interesting. That was Andy. That was really good.
Yeah. So there we are. D is for dark energy. Over to you, Daz.
Right now, this one, D is for Deimos.
Deimos, moon of Mars.
Deimos is the second moon around Mars, along with its companion Phobos. Now, this is only a short one, but it's a literal one. Basically, as I see, I've got the parrot's teeth in, I think. We've got, as I said, it's the moon of Mars. And it was discovered in 1877. But it was predicted by none other than Jonathan Swift. Now, you may know him as the writer of Gulliver's Travels.
Yes, indeed.
Which he wrote in 1726. Now, if you read the book, the astronomers of Laputa reported discovery of 2 moons around Mars. They also declared the orbital periods of 10 and 21.5 hours. They also said that they had a distance of between 3 and 5 Martian diameters.
Wow.
Now, this, but bearing in mind, we're talking, 150 years before they were discovered, was pretty close.
That was pretty close.
The theme was also picked up by Voltaire. And in his sci-fi book, The Micro-Magie.
Oh, yes.
And also, because at the time, the theory was, I mean, we're always looking for patterns. This is how we try to analyze things. We look for patterns.
Yes.
And the theory at the time was given that Earth had 1 moon, Jupiter had 4 moons, which meant Mars should have either 2 or 3 moons.
Right.
As I said, they always love their patterns. Everything's got to have a straight, be a straight line. There's got to be a
in the same way that Mr. Bode and Mr. Titius came up with the Bode-Titius law that we were talking about last week.
Yeah,
where exactly. The distance of a planet from the sun should be twice of the previous one.
Exactly. Yeah. Exactly. Yeah. But basically, in honor of this, there are craters on Deimos called Swift and Voltaire.
Ah, lovely.
And also on Phobos, it has many features named after features from Gulliver's Travels. For example, Laputa Regio and Ricardo Planito, and craters called Clustrial, Drumlow, and Gulliver, of course. So that's my bit of news on this one.
Right.
So it's just a quick one, but I thought, I don't think many people realize that this was predicted by chance or by guesstimate by Mr. Jonathan Swift, and he wrote it in his book Gulliver's Travels.
Well, which
is a very good book.
It is a very good book. Now, the only slight shame about this is that we don't have any good images of Deimos. We have wonderful ones of Phobos, but no spacecraft has ever come close enough to Deimos to take some decent photographs. In fact, the best photographs we have of Deimos, you can see it's sort of potato-shaped and elongated, and it's got a variegated surface of different brightnesses, but I think you can just about see a couple of craters. But that's it. We don't have any good photographs of Deimos. Which is a shame, really, considering the number of spacecraft that have orbited Mars. You think we'd have some decent photos of Deimos by now, but
I mean, it's considered that Phobos and Deimos were originally one object, This
really?
is one theory, and there was an impact which has split them into two, and that accounts for their different types of orbits.
Right.
Because and let me get this right. Phobos, being the closest one, has a deteriorating
Yes, that's going to make a
orbit,
mess on the surface of Mars,
and that's going to make so all those settlers that have settled down on there, make sure you take hard hats because you're going to need them one day. And Deimos is actually is moving away from Mars, and eventually will break free and then shoot off into space somewhere.
So Mars eventually will have no moons.
Exactly. Yes.
Interesting.
The only other thing is, thinking about it, is that as Deimos gets closer, it could actually be torn apart by tidal forces. Gravitational forces, which means Mars could get a ring.
True.
Very true. So you could have Mars with rings around it. So, it's just an interesting scenario. But it's a few years off before that's going to happen. We're not going to be here, but so it'll end up with no moons at all eventually, and maybe it'll have either another crater or it'll have a ring around it. So
I think they've, if I remember rightly, this may not be the case, so don't quote me, but I think I read that Phobos could crash into Mars in about 12 million years' time. Something like that. I mean, it is, in our terms, far in the future. Even though astronomically, of course, it's just tomorrow.
Yeah, like I said, if we've got settlers on there, they're going to need hard hats.
Yeah, definitely.
It's just one of those. But I thought that was an interesting little fact that Mr. Jonathan Swift had picked up on. Well, had wrote about the same scenario as what has turned out true in life.
Amazing, amazing. D is for dawn.
Oh, no. Okay, they carry on, mate.
Now, this could go one of two ways, Daz. I don't know which dawn you've chosen. I'm talking about the spacecraft dawn. No.
Head in hands. Oh,
no. Well, this is the first time that we've both chosen the same thing. So
exactly.
Well, we can both chat about this one. So, I'll tell you a couple of interesting things I found out about dawn. And let's see what you've managed to find out about it. So Dawn was a spacecraft mission launched in 2007 to visit two asteroids. First of all, Vesta, and then Ceres. And of course, Vesta and Ceres, they are slightly different because Ceres is actually classed now as a dwarf planet. It was originally an asteroid, but it's now, like Pluto, a dwarf planet in the solar system. So Dawn visited both an asteroid and a dwarf planet. Now, the first interesting thing about that was it was the first interplanetary probe, if you like, the first probe of the solar system to use ion engines for propulsion rather than conventional thrusters. That's the first thing. And when it went into orbit around Vesta in 2011, it became the first spacecraft to orbit a body in the main asteroid belt between Mars and Jupiter. So it stayed at Vesta for a couple of years and then set off for Ceres, where it arrived in 2015. And Ceres is quite an interesting world because even in the largest telescopes, astronomers could see that it had really, really bright spots on its surface, and they didn't know what these were. Well, of course, when Dawn went into orbit around Ceres in 2015, it investigated those. And there's a big crater on Ceres called Okator crater, and it has got this enormous, incredibly bright spot in its center, which turned out to be a deposit of brine, essentially salty water. And they now believe that this had oozed up from an underground ocean, and Ceres is yet another ocean world in the solar system with an underground ocean containing an awful lot of water. So that's why the spacecraft was notable. It was the first to visit two objects in the asteroid belt, the first to go into orbit around an object in the asteroid belt, and identified that Ceres, like Ganymede, like Europa, Enceladus, all these other water moons, has an underground ocean. And there are no plans to go back to Ceres, but I'm sure they've got enough data to keep them happy for a while. The spacecraft lasted until 2018 when it stopped responding to signals. And they think basically what happened was it ran out of its hydrazine fuel, which powers its thrusters. The spacecraft could not turn itself so that its radio dish was pointing at the Earth, and contact was lost with it because it ran out of fuel, which is very sad because it gave us incredible views and all sorts of information about Vesta and Ceres. Quite a remarkable spacecraft. Is that better about what you've got, Daz? Anything you want to add?
Well, I've got a few more facts that we can chuck in there.
Okay.
As you said, it used the ion thrusters. It had 3 of the engines, but 3 nozzles, but it only ever used one at a time.
Right.
And as you said, it was powered by hydrazine, and basically it was broken down by solar power because it had 2 big panels on there, which basically converted it, gave it its ion thrust.
Sure.
Now, do you know how long it took to get to 0 to 60?
No.
4 days.
4 days.
It took 4 days.
Not exactly Formula One material.
Yeah. The thrust value is very, very low on this thing, but it is continuous. And to give you some idea, it happened to break records for the fastest man-made spacecraft at the time.
Really?
As eventually, when it got up to speed, because it had this thrust just carried on and on and on, it got up to 25,700 miles per hour at the time.
Really?
And that was the fastest man-made object at that time. But as I said, the thrust just continued, and the actual hours of thrust was 51,385 hours of thrust.
My goodness me.
Yeah. So now you imagine that is thousands of times more than all the thrust that was used on the Apollo rockets.
Absolutely, it was.
I mean, you're talking about tens of minutes with all the amount of thrust on the Apollo missions, and most of that was to get it off the ground.
Absolutely.
So it just goes to show how these little engines, how much work they did. And they were efficient. They managed to get it up to 25,000 miles an hour, but it took a long time. So like 0 to 60 in 4 days. So yes, there's a new technology. I thought it was fantastic actually that it actually worked as it did.
Sure.
I'm just seeing if I've got any more. As you said, let's have a look what we got. When Dawn arrived at Ceres, it was the first spacecraft, as you said, to visit a dwarf planet. The first to orbit an asteroid, and again the first to actually do two objects
two
objects at the same time. It also showed us that location of where you are in the solar system was essential to how things developed.
Sure.
On Dawn, on Ceres, it found also organic materials, which are the building blocks of life.
That's right.
If you wanted to know more. A science fact, a fiction to fact, Star Wars far-ranging TIE fighters, that's TIE, which stood for Twin Ion Engine, thanks to its own ion engines. And Dawn broke several records. So the actual in Star Wars, the TIE, they were using ion engines as well. So I'm just thinking that when they scrambled them, they must have taken a long time to get.
I was just about to say that just shows what a whole pile of crap Star Wars is really. Because,
exactly.
With ion engines, they would have had no acceleration.
That's right.
The rebel forces would have been saying to Darth Vader, "Come on, then, if you're that hard, come outside." And Darth Vader would have been saying, "Or just give us a few weeks.
Give us a few weeks, and we'll be there." Yeah.
You can't hurry these things. So
right. I think Dawn revealed that Ceres is geologically active, or was very recently.
Yes, it was very recently.
That was with the ice. I think that's basically it's all covered. There are a few more facts. What have we got here? Dawn by numbers.
There's that enormous mountain on Ceres.
Yeah, and one of the pictures you can see. So on the
it's just a conical mountain standing on its own.
Yeah.
Not surrounded by any other mountains or hills, and they think now that is definitely a cryovolcano.
Yeah, well, is it? Oh,
yeah,
okay,
they're pretty sure that it was, even if it's not active now, that it was a cryovolcano.
Yeah.
So that is a volcano that spews out cold material rather than hot material. So
basically, it took over 100,000 images during its operations. It traveled 4.3 billion miles since it launched.
That's right.
The furthest distance it got from Earth was 300. Let me get this right. 367 plus million miles. It did 3,052 orbits around Vesta and Ceres, and it collected 172 gigabytes of data for science. And as I said, it did 51,400 miles an hour. So there you go.
Wow, that's quite amazing.
Okay then, right. Now I've got to find the one because I'd have to dig that out. All right, here we go. Right, now this one's a little bit of a long one. There's plenty of reading, but I think you'll find this very, very interesting. I did when I discovered it. And D is for Democritus.
Democritus?
A chap called Democritus.
Oh, right.
He lived circa 460 to 370 BC.
Right.
So if you do the maths in that, it actually says there that he was about 90 years old when he passed away, but there are reports that he actually reached the ripe old age of 109. Now, for somebody at that time, that's
pretty good going.
That's pretty good going. Right, if you just bear with me, because there's quite a bit of reading to do with this one, but this chap is well worth a listen. Democritus was known as the laughing philosopher, and he had ideas far in advance of his time.
Right.
He is famous for his atomic theory. Now,
his atomic theory?
Yeah, his atomic theory. Theory featuring tiny particles always in motion through and interacting through collisions. His belief that the universe is governed entirely by natural and mechanical laws,
yes,
rather than God's. So basically, he believed that everything was natural and it actually responded to mechanical laws, which sounds familiar. His description of the universe containing an infinity of diverse inhabited worlds. So again, he believes that there was other worlds. His assertion that nothing is actually something. His deduction that the light of stars explains the Milky Way's appearance, and his discovery, and he also discovered that a cone's volume is 1/3 of that of a cylinder of the same base and height. He wrote eloquently on subjects as diverse as the origin of humans. That's an interesting one. We'll get to that later. Artistic perspective, mathematics, anthropology, biology, medicine, cosmology, poetry, physics, and atomic theory. So he was a busy chap.
He was, wasn't he?
So basically, biographical details about Democritus are sketchy because very few of his writings actually survive, and they think it was possibly because of his belief in the natural world and how things worked, and not by a divine hand. Possibly upset enough people that they really couldn't be, didn't want to look after his writings and all that. But he was never forgotten. So he was born into a noble family about 460 BC in the ancient Greek city of Abdera. After his father died, Democritus used his inheritance to travel widely, educating himself both broadly and deeply. He followed in the footsteps of earlier Greek philosophers such as Thales and Pythagoras, living for some time in Egypt, whose mathematicians impressed him. On eastward travels, he visited Babylon, and he may even have reached India.
Gosh.
He also travels through ancient Greece before settling down again in his hometown. Democritus' personality was calm, tenacious, and cheerful, hence the name the Laughing Philosopher.
Not the Laughing Policeman.
No, not the Laughing Policeman. He believed the main goal of life should be happiness for everyone. And this is one of his quotes. "A life without festivity is a long road without an inn."
Very good. Yeah,
that's a good one. Yeah, he's full of stuff like this, philosophical stuff. He believed that happiness is found in nobility of action. Even if you are not yourself a good person, you can become a good by imitating the actions of a good person, and avoiding excessive self-indulgence. He disapproved of overeating, drunkenness, and promiscuity.
Right.
So I thought you enjoyed a good time. Anyway, never mind.
Sounds like he had a colourful life.
Exactly. He authored a lot of books, which are unfortunately all lost now. But he was regarded as an outstanding writer. He was also interested in the understanding the universe. He was more interested in understanding the universe than in money. He lived simply, often seeking solitude to think more deeply about the world. And again, one of his quotes, he said, "I would rather discover one cause than be king of Persia." So again,
right.
He believed, now this is what I said about anthropology, he believed that humans originated in mud. Now this is a belief that actually runs through a lot of original civilizations, early civilizations, that we actually came from some primordial mud. And at first we lived as wild animals before slowly learning enough to become civilized.
Well, that's sort of how it went, wasn't it?
In a way, yeah.
Amazing.
Plato, who lived at the same time as Democritus, said it was the duty of men to father children for the benefit of the state. Democritus, who did not want children, argued that people should be free to choose for themselves whether or not to raise a family. He also regarded the freedom of the individual as more important than the needs of the state.
Right.
He did not believe in God or gods, believing the world was governed entirely by natural laws. And like I said, this is possibly because of this attitude why his works perished. And like I said, he lived a long life, probably to 90 years, but it has been reported that he was 109 when he actually passed away. Many of Democritus' many works none of his works have actually survived, but some fragments exist, and some of his ideas were discussed by ancient Greek philosophers, including Aristotle, who gave us some details of the atomic theory. Aristotle opposed the idea of the atomic theory himself, believing that matter did not exist as discrete units, but was continuous. The Greek word for atoms means uncuttable.
Yes, that's right.
Modern atomic theory began in the 1800s with John Dalton. More than 2 millennia before this, Democritus' atomic theory argued from deduction and observation rather than experiment. And now these are the points. Everything is made from atoms. Good tip for that one.
Yeah.
Atoms are the smallest particles of matter, too small for us to see, although larger ones could exist. Atoms have existed forever. Atoms are indivisible. They can never be cut into smaller particles. Atoms are separated from one another by the void, a vacuum or empty space. This allows them freedom of movement. Atoms are completely and perfectly solid because no void exists inside an atom. Nah, I got that one wrong.
Yep.
You may cut an apple only because there are spaces between the atoms for the knife to cut into. Atoms are not alive. Atoms cannot be destroyed. sorry, I know this is getting a bit laborious, but
No, go on.
Atoms have been in motion forever and will remain in motion forever. Atoms pass movement between one another by collisions. Atoms are infinite in number. Atoms have an infinite variety of shapes and sizes, leading to the atoms of different substances having different properties.
Right.
Substances differ according to the shapes and positions and groupings of the atoms they are made of. Okay. There is an infinite number of elements, not merely the earth or air, fire, and water, as described by empedocles, whatever his name was. Atoms can link to one another, for example, via convex and concave shapes of individual atoms, allowing them to slot together.
Right.
Objects we can see are made of aggregations of linked atoms. Visible changes are caused by rearrangements and movements of the atoms. So from modern scientific perspective, many of Democritus's statements about atoms are incorrect or flawed. They are also undeniably undeniably profound and indeed brilliant. Democritus explains the whole universe using the theory of microscopic particles. His idea that atoms are always in motion is both correct and exceptional. No better explanation of matter was produced until the 19th century. I could go on with lots of things that he done and what other people have said.
But at the end of it, it sounds like Democritus was one of those people, who pop up from time to time, who were well ahead of their time.
Exactly.
And go completely against the thinking of the time.
Exactly, especially with gods and all that. I mean, when you start messing about with religion and all that, we all know what happens there. Yeah,
absolutely. And also, of course, science as we know it didn't exist then. It was all natural philosophy. There was no science as such. And what always amazed me was that a lot of the Greek knowledge was handed down to the Romans. And the Romans were fantastic architects. They were fantastic engineers. They could do things with water that nobody had ever done before, but they weren't interested in science. There was no Roman science as such. They did science to the extent that they needed to for their aqueducts and buildings and constructions and everything else. But the Romans weren't really interested in science, which always puzzled me, because they were the supremely intelligent people running the Roman Empire, but there was no investigation into anything that didn't relate exactly to what they were trying to do, like build bridges and exactly like that. So that always surprised me.
The only thing I will just read on is in this. I've cut a load out because a great resource of this was called it's Famous Scientists, all one words, lowercase.org. And if you go on there, you can download all this stuff about these people.
Thank you. That's really useful.
And he said, it says meteorology, Aristotle tells us that Democritus believed the Milky Way is made up of the light of stars at night, when the sun's bright light does not obscure their weaker light. This is a remarkable accurate deduction in a time when most explanations of the Milky Way were uninformative or shrouded in mystery. In the early 1600s, Galileo pointed one of the earliest telescopes at the Milky Way and discovered that Democritus was right. The Greek word for Milky Way is galaxias, which also gives us the word galaxy.
Of course.
In his work, Refutation of All Heresies, the Christian theologian Hippolytus of Rome relates Democritus' interpretation of the universe, a place with an infinity of different worlds, some of them inhabited, some worlds prospering, others declining, some with waters, others with none. Right. So he also believed in there was other civilizations out there.
Amazing.
And it also seems that his influence did reach the shores of England, because one of his sayings was, "The world is a stage, life is a performance. You came, you saw, you departed. Now, that sounds a bit familiar, doesn't it?
It does.
Because William Shakespeare said, "The world's a stage, and all men and women merely players.
Yes.
They have their exits and their entrances." So that sounds very familiar. So it sounds like
it does.
So that was Democritus.
Right.
A very, as you
That's
said,
interesting.
a very intelligent chap. And
thank you for telling us about Democritus.
Yes.
Back to me, I guess.
Yeah. Off we go.
Right. D is for the Drake equation, which you have talked about on your program. What is the Drake equation? For anybody who doesn't know, this was an equation created by the American astronomer Frank Drake, which basically tells you how many advanced civilizations, as we would see them as advanced, how many advanced civilizations there are in the galaxy, in the universe. And it's basically a series of multiplications, and you plug in lots of parameters, like the number of planets that have got Earth-like number of stars that have got Earth-like planets orbiting them, what percentage of those can develop life, what percentage does develop life, and you just plug in your best guesses effectively, and it tells you at the end of the equation, when you've done the maths, how many civilizations there are, advanced alien civilizations there are likely to be out there. Now, this is, just an indicator. It doesn't mean that there are any advanced civilizations out there. But what I wanted to talk about specifically in relation to this was that astronomers have recently had another look at the Drake equation with relation to what we now know about exoplanets, that is, planets orbiting other stars. And they fed in the data from our exoplanet studies into the Drake equation, and they've come up with quite an interesting result. When we talk about life in the universe, when we talk about intelligent life in the universe, and by that we tend to mean, extraterrestrials that we could have a conversation with, that we could communicate with, because the vast majority of life in the universe is almost certainly going to be, just tiny living unicellular organisms, bacteria, microbes, this sort of thing. That's probably going to be your average life level in the universe. But if there are any more advanced civilizations out there, once you plug in data about now what we know about exoplanets, having discovered more than 4,000 planets orbiting other stars, they came up with an interesting result. And it says this: human civilization is completely alone in the universe if the odds of a civilization developing on a habitable planet are less than 1 in about 10 billion trillion. So just to explain that, if we are alone in the universe, it means that the odds against an advanced civilization on a planet developing are less than 1 billion trillion. Now, 1 in 1 billion trillion is a tiny percentage. The odds, are going to be, I'm sure, much better than that. But if the odds against an advanced civilization on another planet are less than 1 in 10 billion trillion, then the scientists said that humans are probably alone in the universe. But we don't think that. We think that the odds for advanced civilizations are a bit higher than that. So we're extremely unlikely to be the only life in the universe. Now, another parameter of the Drake equation basically says, how long does a typical civilization last? And this is an effort to try and understand whether there's going to be, just in our own galaxy, a civilization that exists at the same time as ours. And what are the odds against that? And because of that, the Drake equation is you can plug in all sorts of parameters and get all sorts of answers. The answer to that one about how long alien civilizations last is basically we don't have a clue. They may last for 1,000 years, they may last for 10 million years. We have no idea how long a civilization lasts. We've only got our own to go by, and ours is only a few thousand years old. But alien civilizations, what challenges would they face? How long would they last? Would they destroy themselves in their equivalent of, a nuclear war? We don't know. We don't know anything about these other civilizations. So it's all pretty much guesswork, well, educated guesses. But the bottom line about the new evaluation of the Drake equation is that if the odds against an advanced civilization developing on a habitable planet are less than 1 in 10 billion trillion, it means humans are alone in the universe. There we are. Anything to add to that, Daz?
Well, I was just listening to you there. Of course, when you're talking about civilizations and whether or not they still exist, that brings into play things like the Fermi paradox and
yes, absolutely,
things like that. Where have they, used up all their resources? Have they destroyed themselves, or have they polluted their planet? Yep. Topical. Have they polluted their planet to basically they destroy themselves that way? Yeah. There's lots of barriers to these things, these civilizations surviving. But as you said, I mean, basically, Drake came up with the equation, and he says himself that basically there was a meeting. I think it was in 1961. It says here, I think.
Oh yeah.
And because the original. Because as we know, Frank Drake, he founded sort of like the SETI project.
Yes.
But when he first started it in 1960, it wasn't called SETI. It was called Project Ozma.
Oh, yes, I didn't know that.
Yeah, and it was based at... I've lost it now, sorry. It wasn't done at Arecibo to begin with. But
was it Green Bank or something like that?
Well, there was a conference organised at Green Bank,
right?
And this is where this conference happened. And of course, they were all talking about its civilizations and things like that. And he also actually Drake brought a case of champagne because it was actually attended by Melvin Calvin.
Melvin Calvin.
Yeah, Melvin, who was going to be announced as the Nobel Prize in chemistry while they were at the conference. So how he knew that, because it's all supposed to be secret, isn't it?
Yes, of course.
So yeah, so he wrote a list of topics, and what he found is that when they were talking about it, he found that he could put a numerical value to all the things that they were talking about. And this is Frank Drake's own word. He said, I found I could reduce the whole agenda for the meeting to a single line: the Drake equation. Of course, I didn't have real values for most of the factors, but I did have a compelling equation that summarized the topics to be discussed. Sometimes people think the equation is highly speculative. Well, it is in a way.
Yeah, it is.
In fact, it is the opposite. Since each phenomenon, it assumes to take place in the universe is an event that has already taken place at least once, which is true. You know, and that's all we've only had. The only example we've got is ourselves.
Yeah.
So that's how the Drake equation actually came back. And of course, he did the SETI, and he was also involved in sending messages out into space. We know about the Arecibo message; we've already spoken about that. And he was also involved in the plaques and the records that were sent out on Pioneer and
Voyager,
the Voyagers and all that. Yeah. So he's been a busy chap. He's still around.
Oh, he is still around, and I was watching an interview, a chat with him that Brian Cox did not so long ago, and Brian Cox asked him, are you disappointed that when you said in the 20th century that we will have found extraterrestrial intelligence by the end of the 20th century and it hasn't happened? He said, yes, I'm very disappointed. He said, but not surprised. He said, it turns out that these things take a lot longer than we thought. He said, and we need to do it a lot more rigorously. We need to do it a lot more scientifically, and just give it more attention and resources, basically. Because SETI's always had this problem with resources, hadn't it? It was Paul Allen, Microsoft's co-founder, who stepped in and basically saved it, and who built that lovely array of antennas in I can't remember where it is now, somewhere in America, and. It's always relied really on private donations because governments don't want to get involved with it. They don't see any return on SETI because, the odds against finding signals from extraterrestrials are so astronomical that no government really wants to spend money on it. To them, it's money down the drain, and you can see that point of view as it's taxpayers' money.
Exactly.
So the whole SETI field is really privately funded. But there we are. So that was the Drake equation.
And as you can guess, because I'm filling you in on these things and all that, I mean, he did actually do some astronomical things and all that. He was the first person to actually map the center of the Milky Way.
Yes,
using the radio telescopes and all that.
No, he's a very, very accomplished guy.
I'm just trying to find, because when he set up Project Ozma, the very first day they did detect a signal. Here we are, Project Ozma, listening to aliens.
So what day was this, sorry?
This is 1958.
Oh, right. Now that rings a bell that year.
Yeah. Yeah, exactly. Oh, something's very special that happened that.
Yeah, two things very special happened that.
Exactly. If you just bear with me a second. They received a signal, and they thought basically they were all up in our, all joyful about it, all excited. But basically they said they were talking about sort of like going public with, but in the end they suppressed it, saying it's just too unlikely that we would detect on the very first day a signal. And Drake put it down to a radar blocking system being used by the nearby airbase and all that.
Nearby airbase, that's a bit.
But then, of course, exactly. So he did that, but then, of course, what happened then is that all the conspiracy theories started around it, saying that the news of actually hearing ET was being suppressed by the government and all that.
As ever.
So so it brought out the tinfoil hat brigade. So yes, he did a lot of things. He did some work on Venus and things like that. His work helped sort of like map the surface of Venus,
right,
and other stuff. So he did other stuff rather than actually do the SETI. Although his his main goal was to find extraterrestrial life. He's still looking, because he's still the director of SETI, as far as I remember.
Yes, as far as I know. Yeah. Right. Well, I guess it's back to me then, Daz. So D is for dinosaurs. Let me explain. It's all to do with the extinction of the dinosaurs. There's been some new research come out of Montpellier University in France. And it's very interesting. Just to set the scene, we know that 65 million years ago, a massive asteroid, maybe about 6 miles across, slammed into what is now the Yucatan Peninsula in Mexico. And this has been commonly cited as the thing that killed off the dinosaurs, made them extinct. But in recent years, another impact was discovered in Eastern Europe. And it dates from about the same time. Not as big an object, but it did slam into Eastern Europe. I think it was into Ukraine, if I remember right. Although I can't be sure of that. At first, scientists thought that these two impacts happened very closely together in time, and that between them they killed off the dinosaurs. Well, firstly, they've now established that the second impact in Eastern Europe happened about 500,000 years after the Yucatan event. So it couldn't be responsible for killing off the dinosaurs, because by then the dinosaurs were long gone. But now the team at University of Montpellier have come up with a really interesting idea. And that is that because of climate change, dinosaurs were already in decline 10 million years before the Yucatan event. And the way that the climate change killed off or helped to kill off the dinosaurs was that it reduced the diversity of their species, in particular herbivores. And herbivore numbers they've discovered after some very, very painstaking and detailed research. The numbers of herbivore dinosaurs declined dramatically in the 10 million years leading up to the Yucatan event. Now, obviously, if there are fewer herbivores, there's less food for the carnivores to eat. So both herbivore and carnivore dinosaurs went down in numbers dramatically, and they say that the Yucatan Peninsula was the Yucatan event was the impact that finally drove the last nail into their coffin. In fact, they say that at the time of the Chicxulub event, as it's known more properly, there may have been only one species of T-Rex left, because the diversity of the dinosaur species had suffered due to climate change. And it's an interesting idea. You know, there's going to be lots of opposition to it because it goes against really what a lot of people think. But they've done some really detailed research, and they've got the data to back up their ideas. So it may have been climate change that precipitated the downfall of the dinosaurs, with the Chicxulub event just finally finishing them off.
Okay, then. Do we know what caused the climate change?
They suspect that volcanism is at the heart of it.
Right. Okay, and that would make sense. Yeah, because you could get it wouldn't be atomic winter.
No, because you had the Deccan traps in India pouring out, vast quantities of lava for hundreds, or if not thousands of years.
Of course, that would interfere with the atmosphere and everything.
That's right. Yeah. So it's all a very interesting bit of research. So there you are. I just thought I'd bring that up because it's hot off the press research.
As you said, with no herbivores, there's nothing for the predators to predate.
Nothing for the carnivores to eat.
Okay. Because the thing is, it makes me. You're talking about huge craters. Did I see something the other day? I'm sure I did, or I may have been dreaming. But they reckon that Paris actually sits in a huge crater.
Really?
Meteor strike. Yeah, I saw something, and there was dotted lines and saying this was the limits of the crater.
Wow, I'll have to look that up. Thank you.
Yeah, I may have. I could be leading you down a blind avenue, or I saw something and it was related to craters, and they may have even used it as an indication of how big the craters was. But I've seen when you have Meteor Day or Meteor Week. I have seen them show meteor craters, and some of them do cover huge areas, and within inside these craters there's villages, there's towns and all that, all spread out in these craters, and they didn't even know the crater was there.
Goodness,
they just thought the surrounding hills, which would be the crater walls and all that, were things. So yes, there are lots of, and of course, we've only been able to discover these things by using space.
Well, that's right. I mean, with the era of Earth observation, we're discovering more of these ancient craters.
Yeah, the further away you are, the more you're going to see them. Oh, that was interesting, Andy. Okay, then. So. Oh, so they were on their way out already. Oh, bless them.
I mean, they've thought for a long time that they were already on their way out, but there was no specific mechanism for it. They knew that volcanism probably had something to do with it, but they couldn't come up with an exact mechanism. But this new mechanism of the diversity of the different species dwindling seems to make a lot of sense.
Yeah. And I suppose there would be some trace of it in the fossil record and all that as well.
Yeah, so,
well, like you said, they've done all their research, so I'll keep an eye out for that.
If you want to look it up, if you look for that, it's research from the University of Montpellier. So you should be able to find it. If not, Daz, I can just send you a link to it.
Yeah, no, that's great. That's fine. It'd be interesting, that one. Right,
goes
then.
into a lot more detail about the actual species and which ones died out.
Yeah. Okay. Then. Yeah. That's
okay.
Fine.
Over to you then, Daz.
Okay, then just a quick one from me as well. D is for Doppler spectroscopy.
Doppler spectroscopy. Wow. Okay.
Yeah, Doppler spectroscopy, and I can say it without stuttering. I've been practicing that one. It's also known as radial velocity method, or as we all know it, it's called the wobble method.
Right.
It's basically an indirect method of finding extrasolar planets and brown dwarfs from radial velocity measurements via observation of Doppler shifts in the spectrum of the planet's parent star.
Yes.
Basically, what that means is, as we know, if you've got a large planet or even a smaller terrestrial planet, which is made up of rocks and all that, as it orbits its host star, it actually makes it wobble slightly. It moves backwards and forwards, and
it's a very slight movement.
And it's a very, very slight movement, but it's usually in spectroscopy, because, as we know, anything that's moving away from you shifts into the red. Anything that's coming towards you goes to the blue. But really, you need spectrographs that are so sensitive that they can detect these very small movements. And it was Otto Struve proposed in 1952 the use of powerful spectrographs to detect distant planets. He described how a very large planet, as large as Jupiter, for example, would cause its parent star to wobble slightly as the two objects orbit around their center of mass. He predicted that the small Doppler shifts to the light emitted by the star, caused by its continuously varying radial velocity, that means how it sort of moves around itself, would be detectable by most sensitive spectrographs as tiny red shifts and blue shifts. So that's basically what it was all about. And using this method, they found hundreds of these stars. Let's have a look. I did have somewhere where it's talked about velocity shifts as low as 7 meters per second, low enough for an extraterrestrial observer to detect Jupiter's influence on the sun. Using this instrument, astronomers Michael Mayer and Didier Guzlos identified 51 Pegasi b as a hot Jupiter in the constellation of Pegasus. Although planets had previously been detected orbiting pulsars, 51 Pegasi b was the first planet ever found orbiting a main sequence star, and the first detected using Doppler spectroscopy.
Wow.
Spectroscopy. Oh, I blew it.
nearly nailed it.
Nearly got through it. But since then, of course, spectrographs have become more and more sensitive, so they've been able to detect more and more exoplanets or brown dwarfs or anything like that. So yes, but that's what it is. It's Doppler spectroscopy, and that is detecting the wobble.
It's now not the major way that we're finding exoplanets. We're finding exoplanets mainly because they pass in front of their star and cause a dip in the light of the star. And we're only talking about maybe 1%, but the instruments now are so sensitive that they can detect a drop of 1% in the light of a star, which is quite amazing when you think about it. But then you see, that brings us to another interesting point. We only see those planets because they're passing in front of the star. If they're actually not orientated that way, so that in fact you turn their orbit through 90 degrees, we'd not seeing them at all. So for every exoplanet that we are detecting by measuring the dip in light from the star, there's probably thousands of others that we'll never detect that way.
You would only detect if it was, like I say, through 90 degrees, where it was orbiting sort of like north-south over what we would call the poles. You would just detect a very slight movement in the star. But but with the spectroscopy you can tell where how
of course,
big
the other thing about Doppler spectroscopy is that we can't use it for faraway stars because they're simply too far away to have their Doppler shift measured. So interesting, very interesting.
Very good. So that was a quick one for you,
because we're up to I don't know what the latest count is, but last time I looked it was just over 4,000 exoplanets.
Yes, we're way up in the thousands
that we've now detected orbiting other stars,
through different means and stuff like that. So that's fantastic.
So there we are. All right, great, thanks for that then, Daz.
That's fine.
Well, that brings us to the end of another episode of the Amazing Astronomical Alphabet. This week we covered the letter D. Next week we'll be back with the letter E. If you'd like to comment about the program or suggest anything or anything you want to say, you can email me at andy@astroradio.earth. It's been a good week, hasn't it, Daz? Really interesting.
It certainly has. I mean, I just don't know where all the time goes. I mean, it looks like we only started about sort of like 10 minutes ago.
I know.
But yeah, it's great fun. It's great fun. I mean, I learn something every week. Well, I have done so far.
Yeah, me too.
And
Me too.
I hope, you know, it's the subjects are all varied. And although this week we did have a couple the same.
Yes.
The first time.
But that's to be expected. But
yeah.
your one about Democritus was really interesting. I'm going to look further into that.
Yeah, I mean, I found him quite by mistake, and I thought, well, I'll have a look at it. As I said, if you are interested, the site where you'll find lots of different scientists was famous scientists, all in lowercase and in one word. .org.
Right, I shall see
you'll find. Yeah, you'll find lots of people of interest in there, hundreds of them.
Yeah. Okay. Well, thanks for listening, listeners. We hope you've enjoyed the program as much as we have making it.
Yeah.
So we'll see you next week when we tackle the letter E on the amazing astronomical alphabet. Until then, have a fantastic week and goodbye from Daz and myself.
Yeah, stay safe, everybody.
That's the important thing. Bye.